next let's look at question 2. Um, it reads that an airplane flies at an altitude of 5 miles towards a point directly over an observer, like in this figure. The speed of the plane is 600 miles per hour. Find the rate in radians per minute at which the angle of elevation theta is changing when the angle is A 30, B 60, and C is 75 degrees. So the reason I found this problem annoying is that the setup is actually like the most involved part of this problem. And I found it annoying because we go straight from picture to part A and there isn't even space to set it up. And I feel like, it doesn't kind of even indicate that setup is actually going to be a lot of work. So let's go off to the side and try and set this problem up. And we're going to spend a considerable amount of time on that, and then I'm going to leave it up to you to actually use the setup to answer part A, B, and C. So yeah, let's get into the setup right now. And I've drawn a triangle representing what's in the picture there. So the opposite side has length 5, like 5 miles, and the angle is theta as given. And I've just gone ahead and named that side that measures the horizontal distance between the person and the plane. I've gone ahead and named that side x, right? And the reason I've done that is because the question tells us actually what dx dt is. Namely, it is, so dx dt is 600 miles per hour. So that's why I felt it was important to give a name to that side, because we're told information about the derivative of that side in the question. Okay, and now comes the time to relate all these three quantities that we have, because this is a related rates problem, right? We know the rate at which x is changing. We want to figure out the rate at which theta is changing. And so let's write down a relation between these three quantities, and we know that tan theta must be 5 over x. And you can set up this relation in so many different ways and use that to kind of relate the rates of x and theta. And every different way that you try is going to look a little bit different. And so, I encourage you to try different ways, but I'm just going to pick one, and I'm going to rewrite this as x equals 5 over tan theta. And the reason I did this is because I was thinking a few steps ahead and realized that this would be the easiest route to take. But if you have set your equation up differently, that's perfectly correct. It just might be a little bit more steps. Okay, so I've gone ahead and changed my equation into this form, and then I take derivatives on both sides. And so on the left-hand side, I just have the derivative of x, and on the right-hand side, I have to take the derivative of 5 over tan theta. So I'm going to use a chain rule, and so I have a composition of quite a few things going on here, right? So chain rule, first I'm going to derive, what is the derivative of 1 over something, so that gives me the 1 over tan square theta. And next I'm doing the derivative of the tan theta, which is secant square. Finally, a derivative of theta with respect to t. So chain rule there, that gives me this relation between the rates of x and theta. And we're interested in understanding theta prime. So I just solve for theta prime. I plug in the derivative of x, which is 600 miles per hour, and I get this expression. So check that you get the same thing from that step to the next. And note that the units are in radians per hour. All right, and so in part A, you're going to have to figure out what is theta prime at theta equals 30 degrees. And in part B, theta is 60 degrees. And in part C, theta is 75 degrees. So really, at this point, you've done all the heavy lifting already. The other thing that I will point out is that right now the units of theta is in radians per hour. So we might just, and the question asks for us to figure out the rate in radians per minute, right? So let's really quickly change our units. So in order to write this in radians per hour, this would actually be equal to minus 1, or sorry, in order to write it in radians per minute, I should have said minus 120 sine squared theta divided by 60 radians per minute. And so you can simplify that a little bit. But yeah, once you've set this up, then parts A, B, and C are pretty straightforward. So I'm going to leave it at that.